Problem 5, writing equations of lines. A sports item, the baseball field below is on a coordinate grid with home plate at the origin. A batter hits a ground ball along the line shown. The player at coordinates 110, 70 runs along a path perpendicular to the path of the baseball. What is an equation of the line on which the player runs? So this is going to be a really similar process to what we've already completed. What we have is a line. We'll need to find its slope. That's the slope of the path of the ball. We have a point that our perpendicular line is going to pass through. And so we start with step 1. Find the slope of the baseball's path. And we identify 2 points on that line. I see an x value of 60 along with a y value of 20. Try to indicate where those are coming from. A y2 of 20 and x2 of 60. So we're talking about this as being one of the points. A y value of 10 going along with an x value of 30 being the other point. We could have used the origin as well, but in any case we'll get the same slope as long as we perform the process correctly. And we'll find a slope of 1/3. So again, that's the path of the ball. Slope of 1/3. We know the player is currently at the position 110, 70, so that's a point that's going to be on this perpendicular line. And before I change slides, let's make sure we understand the opposite reciprocal of 1/3 is going to be -3. Or, if we want to think of it for slope purposes, -3/1. Step 2, the slope of the perpendicular line, -3. Step 3, we're going to write the equation of the line on which the player runs using the 3 pieces of information that we've just discussed. Substituting in -3 for slope, 110 for x1, and 70 for y1. Arriving at the equation, y minus 70 equals -3 times the quantity x minus 110. And it's your turn. A similar question. The baseball field shown is on a coordinate grid with home plate at the origin. A batter hits a ground ball along the line shown. Suppose a second player, standing at 90, 40, misses the ball, turns around, and runs on a path parallel to the baseball's path. What is the equation of the line representing the player's path?